Now that we understand the distinction between object references and objects, we'll look at some more capabilities of function arguments. The formal function arguments specified when a function is defined with the def keyword are a comma-separated list of the argument names. These arguments can be made optional by providing default values. Consider a function which prints a simple banner to the console. This function takes two arguments, the second of which is provided with a default value, in this case a hyphen, in a literal string. When we define functions using default arguments, the parameters with default arguments must come after those without defaults, otherwise we will get a syntax error. Within the body of the function, we multiply our border string by the length of the message string. This shows how we can determine the number of items in a Python collection using the built-in len function, and secondly, how multiplying a string, in this case the single character string border, by an integer, results in a new string containing the original string repeated a number of times. We use that feature here to make a string equal in length to our message. We then print the full width border, the message, and the border again. When we call our banner function, we don't need to supply the border string because we provided a default value. However, if we do provide the optional argument, it is used. In production code, this function call is not particularly self-documenting. We can improve that situation by naming the border argument at the call site. In this case, the message string is called a positional argument and the border string a keyword argument. The actual positional arguments are matched up in sequence with the formal arguments, whereas the keyword arguments are matched by name. If we use keyword arguments for both of our parameters, we have the freedom to supply them in any order. Although, remember that all keyword arguments must be specified after the positional arguments. It's crucial to have an appreciation of exactly when the expression provided as a default argument value is evaluated, to avoid a common pitfall which frequently ensnares newcomers to Python. Let's examine this question closely using the Python standard library time module. We can easily get the time as a readable string by using the ctime function of the time module. Let's write a function which uses a value retrieved from ctime as a default argument value. So far so good, but notice what happens when you call showDefault again a few seconds later. And again. The displayed time never progresses. Recall how we said that def is a statement that when executed binds a function definition to a function name. Well, the default argument expressions are evaluated only once when the def statement is executed. Normally this causes no problems when the default is a simple immutable constant, such as an integer or a string, but it can be a confusing trap for the unwary that usually shows up in the form of using mutable collections as argument defaults. Let's take a closer look. Consider the function which uses an empty list as a default argument. It accepts a menu, which will be a list of strings, appends the item spam to the list, and returns the modified menu. Let's create a simple breakfast of bacon and eggs, and naturally add spam to it. We'll do something similar for lunch. Nothing unexpected so far. But look what happens when you rely on the default argument by not passing an existing menu. When we append spam to an empty menu, we get just spam. Let's do that again. When we exercise the default the second time, we get 2 spams, and 3, and 4. What's happening here is that the empty list used for the default argument is created exactly once, when the def statement is executed. The first time we fall back on the default, this list has spam added to it. When we use the default the second time, the list still contains that item, and a second instance of spam is added to it, making 2, ad infinitum, or perhaps ad nauseum would be more appropriate. The solution to this is straightforward, but perhaps not obvious. Always use immutable objects, such as integers or strings, for default values. Following this advice, we can solve this particular case by using the immutable none object as a sentinel. And now our add spam function works as expected.